Myself, Dr. B. Sridhar, Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Now we are going to discuss about the topic light emitting diode. So we will see the list of content, the light emitting diode and the diode operating characteristics. First of all, in optical fiber communications, the main major elements are fiber, optical sources and photodetector. Let us come to the optical sources. Majorly we are using LED and laser. These two only majorly we are using. Okay. So, the LED, the expansion of LED is nothing but light emitting diode. And come to the laser. The laser is nothing but the light amplification by simulated emission and radiation is nothing but laser. Now, the LED and laser are the two sources we know very well. Here, the LED is suitable for the short distance communications. So, whenever we are preferring the short distance communications, so we can use LED as a optical sources and low bitrate applications. So, these two, wherever it is applicable, so that junction, so here we can use the LED. For coming to the laser or the coherent device, it is suitable only for the long distance communications. Also, it has high bitrate applications. So, LED and laser are the two sources. So, for short distance LED or longer distance, you can use laser. Fine. Now, let us come to the light emitting diode. Here the name implies here the diode. Here the light emitting diode, it is a specialized form of PN junction diode. So, from a very thin layer and fairly heavily doped semiconductor material. Now, we know that the diode has two conditions, the forward bias and reverse bias condition. Okay. Whenever the diode is in the forward bias conditions, the electrons from the semiconductor, okay, the conduction band recombine with the holes from the valence band, releasing the sufficient energy to produce the photon which emits a monochromatic of light. This is a major thing in this specialized LED. Generally, we know that in the electrons holes per recombinations, here the electrons and holes are recombined. Okay, it forms some junction. So, from the junction only here we can emit the energy. But here at a junction, so here it produces a photon which emits a monochromatic of light. So, this is a major thing in the specialized LED. Okay. So, not only that, a thin layer of a reasonable number of photons can leave the junction and radiate away, producing a light as a output. So, this is a major thing, so which is present in the LED. Fine. Here, let us consider the conventional PN junction diode. It is a homo junction, it is like a semiconductor material. Okay, both the side we have the junction. Okay, so generally this electrons holes per recombinations relatively it may be here the 10 micrometer, and not only that, the carrier confinement. So, it may be resolved by sandwiching a layer of 0.1 micrometer. So, this between the P and N type. So, here for confinement, so here we are using some 0.1 micrometer for like a sandwich layer. Okay. So, now, so this carrier confinement, even it's a 0.1 micrometer confinement, also the majorly is saying the carrier confinement occurs due to band gap discontinuity of the junctions, even though it is 0.1. So, such a junction is called a heterojunction. Okay, and this device is called a double heterostructure. Fine. We will go to the structure of LED. Here, here the P type and N type materials are connected. Here, see, this is anode, this is cathode, this is a base. So, as I said earlier, here this electrons holes per recombinations. These electrons holes per recombinations. Okay, so it can radiate energy in the form of light. Fine. Now, Let us see. It's a, as we know that it's a specialized type of PN junction diode. Okay, so the material which are using in this LED or GaAs is nothing but gallium arsenide. Okay, so gallium arsenide, this kind of material, okay, so which can emit the source. Okay, so generally, so this applications belongs to the remote control. Wherever we are in remote control lights, okay, so we are using this gallium arsenide material. Okay, we know that in remote control we have the LED. Okay, whenever we are pressing the button, that here that light can emitted out. Okay, so that what type of material we are using, in the sense here we are using the gallium arsenide. Okay, suppose if you want to change the color, suppose I want red color or green color lights. Okay, so at the time you have to change the material. Okay, so what type of material, in the sense gallium phosphide. So gallium phosphide material, if you use this gallium phosphide material, okay, so then you can get the red color emission or a green color emission of light. Okay, sometimes we may require different colors of light. Okay, so GaAsP is nothing but gallium arsenide phosphide. Okay, so here in these combinations we give either red color or yellow color light. So these three major material we are using in the LED, okay, for emission of light signal. Fine. Now homojunction LED. So as we know that it's like a PN junction diode, it's like a single semiconductor material. Okay, so here this homojunction LED or a surface emitters. See, the main thing, it's a surface emitters giving off light from the edges of the junction. Okay, so giving off light from the edges of the junctions as well as this entire plane. But these homojunctions will lead only the low radiance output. Low radiance output. So we know that here, if we see here the P type, here the N type, here is a depletion lateral form. Okay, so here that junction, okay, so here it can emit the light signal. But the main thing here is, here in this homojunction LED, it can give only the low radiance output. Okay, so next to overcome this, so we can go for some heterojunction LED. Here we can introduce another layer. Here in the junction layer, here we can introduce some indium gallium arsenide phosphide here. Okay, so in the P type we are using the indium phosphide, in the N type we are using the indium phosphide material, no issue. Okay, so here the name hetero, here different structure of material you can introduce in that band gap. Okay, so here we are using the some indium gallium arsenide phosphide. Okay, so if you use this kind of different energy levels, okay, then what will happen? Then it creates the high radiance output. Okay, so the main major thing is this difference confine the carriers and provide more directional output for the light. This is a major thing present in the heterojunction LED. That's why you can prefer the heterojunction LED, okay, rather than homojunction LED. Fine. Now if you see this band gap diagram, okay, so here the first stage the metal contact, the last stage metal contact. Okay, so here we are using the substrate material. Okay, here this N type gallium arsenide substrate material, here the P type gallium arsenide substrate material. Okay, so here again, here this N type and P type the gallium aluminum arsenide. Here this is the heterojunction layer. This is a heterojunction layer. Okay, so what we discussed here previously, the same one, here this layer is introduced here. If we observe, if you observe this one, so here see here this electrons holes per recombination is more in this area compared to remaining area. So which gives the high radiance of output. Which gives the high radiance of output. So this is the major principle behind the heterojunction LED. So if you observe this graph also, we see the active region is more in this region, in this area. Okay, so that's why we are introducing some material in between the band gap. So far we discuss about the LED structures and homojunctions and heterojunctions. Fine. Thank you.